Let's talk about density, one of our properties of matter that we're looking at in this unit. Density is the relationship between the mass of an object and its volume. Okay, so mass divided by volume is density. And typical units that we use are either grams per milliliter or grams per cubic centimeter. Note that the numerical values of these densities would be the same since a milliliter and a cubic centimeter are the same volume. So if we have a question like this, where we have the mass of a metal and its volume, then to find its density, we do a simple division. Okay, and here our final answer, you'll see, is rounded to 3 significant figures, and that's because we're doing a division and our volume has 3 significant figures, our mass has 4, so we're going to round our answer to 3 significant figures. Sometimes when we are finding density, our object that we're looking at does not have a regular shape, meaning not something that we can get its volume by using a ruler to measure the length, width, and height. And in that case, we can use water displacement. And basically what happens is that we start off with our initial volume of water. In this case, we have 25 milliliters. And once we add the object, the volume increases to 33 milliliters. The difference in those volumes, the initial and the final, that is the volume of the object. So using this example, what if this piece of metal that I dropped in the graduated cylinder has a mass of 48 grams? What would be the density? Okay, the answer would be 6 grams per cubic centimeter. And we get that from our volume, we said was 8 milliliters, which a milliliter and a cubic centimeter, same volume. And then we divide our mass, 48 grams, by the 8 cubic centimeters, and that gives us a density of 6 grams per cubic centimeter. If we have several liquids that we are comparing, we can actually layer them. If their densities are different enough, we can layer them in a graduated cylinder. As you would expect, the greater the density, the lower it will sink relative to the other liquids. So in this one, we would expect to see the Karo syrup on the bottom, and then the water in the middle, and then the vegetable oil on the top. Okay, we can use density as conversion factors in factor label type problems. And in fact, if you are uncomfortable with rearranging the density equation to find different things, like solving for grams or solving for the volume, using it as a factor label really helps that. Okay, so let's look at an example of how we would do that. Here we have the density of octane as 0.702 grams per milliliter, and it wants to know the mass in kilograms of 875 milliliters of octane. All right, here we got a word problem. The thing to remember is that if it gives us a relationship between two different things, that's going to be used as a conversion factor. Okay, so here our density gives us the relationship between grams per milliliter, so that we're going to use as a conversion factor. And this volume, that's our known, the thing we're trying to find, or the thing we are given, and then the mass is our unknown, the thing that we're trying to find. So how would we lay that out with a factor label? Well, we're going to start with the volume that it gave us. Here we want milliliters to cancel. Okay, so we're going to use our density, and then it wanted it in kilograms, so then we're going to convert finally from grams to kilograms. Okay, if you're not quite as familiar with the factor label, you might want to stop and go look at the discussion on factor label and then maybe come back to this part of this discussion. But this would be how you would use density in a factor label type problem. All right, let's look at another one. Here we have blood has a density of 1.05 grams per milliliter. How many liters of blood are donated if 575 grams of blood are given? Again, the grams, that's the quantity that we're given, and the density it gives us is the conversion factor. And so here, if we look, here we want the grams in the density. We're going to put the grams on the bottom so that our grams will cancel. That gets us to milliliters, and then we're going to use this conversion factor that 1 liter is 1,000 milliliters to get our final answer of 0.548 liters. All right, here's another one, another word problem for you. Here we have 125 empty aluminum cans, and it says if 21 cans make 1 pound of aluminum, how many liters of the aluminum are obtained from the cans? Well, let's look at this. Lots of numbers in this word problem, but again, remember, if it's given you a relationship between two things, that's typically going to be used as a conversion factor. If it's just given you an amount, that's typically going to be the thing you're going to start with. So here we have our amount is the 125 aluminum cans. And what relationships is it given us? Well, we have that 21 cans equals 1 pound. And then we also have the density that 2.7 grams is equal to 1 cubic centimeter. So we've got two conversion factors that we can use. And where are we trying to find? We're trying to find a volume of aluminum that we could get from these cans. So here we have a multi-step, and this one's kind of runs through here, but you can see we start with 125 cans. Then here's one of the relationships we're going to use from the problem. Okay, 1 pound is 21 cans. Now, in order to use our density value, which is in grams per cubic centimeter, we need to convert our pounds that we have our mass here into grams. And so here would be a conversion factor between a metric and English unit for mass, and you would look this up. 1 pound is 454 grams. Then we can use our density. That gets rid of our grams, or it gets rid of our pounds. Now we're in grams. So now to get from the mass to a volume, because remember we're trying to find the volume of the aluminum, grams would cancel using our density. And then it wanted it in liters, so we're going to go from cubic centimeters to milliliters. Those are equivalent units. And then from milliliters to liters in the last step right here. So our final answer is 1 liter. Okay, one last question here. Here I have 3 metal samples. I want to know which one will displace the greatest volume of water. Okay, so let's look at these then. We have 25 grams of aluminum, and it says aluminum is 2.70 grams in 1 milliliter. So that gives me a volume of 25 divided by 2.7. So I get 9.3 milliliters. And then I have 45 grams of gold. Is my given, and 19.3 grams is 1 milliliter. So I have 45 divided by 19.3, so 2.3 milliliters, and then 75 grams of lead, and I have 11.3 grams is 1 milliliter of lead. So 75 divided by 11.3, and I get 6.6 milliliters for that one. So the answer is aluminum.